بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول درس جديد في مادة الاستاتيكا وهو بمعنى الازدواج. قبل. طبعا الازدواج موجود في حياتنا اليومية. Two forces or قوتين equal in magnitude, opposite direction, the acting of line don't lie on the same straight line meaning the couple. مهم جدا درس النهارده اللي هو الازدواج، وفي طبعا محصلة الازدواج very important lesson to solve our problems in static. Welcome my dear student in our math program for secondary 3. Today we are taking the lesson in static subject. It's called or its title the couple. What is the meaning of the couple? Couple, we have two forces equal in magnitude and opposite in directions, and the acting of the two forces don't lie on same straight line. My dear student, we have two directions of couples, positive or negative direction. When couple anti-clockwise is positive, when couple is clockwise direction is negative. Don't forget, the couple is product of the force and the distance between the two forces. My dear student, let we say to go. What is the meaning of the couple? How to use couple to solve many problems in static? My dear student, look at definition of the couple. Look at, my dear student, it is the system of two forces are equal in magnitudes, also in opposite direction, and acting in different line of action is called a couple. System of two forces equal in magnitudes, opposite direction, acting line in different line of action is called a couple. The moment of couple. A couple has moment. My dear student, look at the first figure. We have two forces, F, and the distance between them, AB, equals L. This couple is positive. Why? Its direction anti-clockwise. Moment F times L. F the force magnitude, L the distance AB. The second, the two forces but in clockwise. Direction is negative. Then the moment equals negative F times L. The norm of the couple equal norm of BA times F, ABF sine theta. Therefore, M equals FL. Why? Sine theta is sine 90. Sine 90 equals 1. Then the norm of the couple equals product of the force times distance L. My dear student, important rule. If three coplanar forces act on a rigid body and they are completely represented by sides of triangle taken in the same cyclic order, then the system is equivalent to couple. My dear student, if we have three forces represented by sides of triangle taken in the same cyclic order, then we deduce this system equivalent to a couple. The magnitude of its moment equals K equal ratio between the force times L, force over L, and multiply area of triangle. Look at, my dear student, ABC is in triangle. F1 acts at AB, F2 acts at BC, F3 acts at CA. Then three forces F1, F2, F3 act at AB ray, BC ray, CA ray, and respectively in cyclic order. Then we deduce that F1 over AB equals F2 over BC equals F3 over CA equal constant K. The constant K is ratio between the force and the side. Example: ABCD is a parallelogram in which AB 12 centimeter, BC 8 centimeter, measure angle A equals 60 degrees. Forces of magnitudes 6, 10, 6, 10 kilogram weight act along AB ray, CB ray, CD ray, AD ray, respectively. Prove that the system is equivalent to a couple and find its moment norm. Look at solution. ABCD is a parallelogram. AB equal 12 centimeter and BC equals 8 centimeter. We have forces 6 and 6 act at AB and CD ray. Also, we have two forces 10 and 10 act at AD direction, CB ray. What is the moment of this couple? Look at my dear student. BE is distance between the two forces which act at CB and AD. We need perpendicular distance between the two forces 10 and 10, BC and AD. BE is perpendicular distance between the two forces. How to find BE? Look at in triangle BEA. Measure angle A equals 60. Then we deduce that BE over AB equals sine 60. Then we deduce BE equals AB sine 60. We know that AB 12 sine 60 root 3 over 2. Then 12 times root 3 over 2, answer 6 root 3 centimeter. Remember, BE distance between the two forces 10 and 10 which act at CB ray and AD ray. Also, DH is perpendicular distance between other two forces 6 and 6 which act at AB and CD. How to find DH? By the same method, DHA in triangle DHA, DH over AD equals sine 60. We deduce that DH equals AD sine 60. Find the value. DH 8 sine 60, 8 times root 3 over 2 equals 4 root 3. Remember, my dear student, we have two couples. The two forces 10 and 10 form a couple. Its moment M1. Then M1 equals negative 10 times BE. Why negative? Excellent student, because the two forces act in clockwise is negative direction. Therefore, we substitution about BE equals 6 root 3, then M1 equals negative 60 root 3 kilogram weight centimeter. Remember, my dear student, unit of the moment of the couple is kilogram weight dot centimeter. Why? Because the moment equals force times distance. The force in kilogram weight, but the distance centimeter, then the unit of this couple is kilogram weight centimeter. By the same method, my dear student, we have 6 and 6 form a couple. Its moment M2. What is the moment of this couple? M2, 6 times dH. We know that dH equals 4 root 3 multiply 6 equals 24 root 3 kilogram weight centimeter. Then what is the summation of set of forces form couple? It's moment M1 plus M2. We add M1 and M2. Answer is negative 36 root 3 kilogram weight centimeter. Therefore, the norm of moment is positive 36 root 3 kilogram weight centimeter. Another example. ABCDHO is a regular hexagon. What is the meaning of regular hexagon? All sides equal in length, all angles equal in measure. Measure of each one equals 120. Length of whose side is 8 centimeter. Forces of magnitudes 3, 8, 3, 8 kilogram weight act along AB ray, CB ray, DH ray, OH ray respectively. What do you mean respectively? The force 3 act at AB ray. The force at CB ray. The force 3 at DH ray. The force 8 acts at OH ray. Prove that the system of forces is equivalent to a couple and calculate its moment. Solution. Look at, my dear student, in the opposite figure we have 3, 3 form couple, 8, 8 also form couple. We have two couples. First, we calculate the distance AH and BO. AH line between the two forces 3, 3. BO the distance between the two forces 8, 8. Therefore, my dear student, we know that AH 16 sine 60. Why? We know that, my dear student, in triangle AHB, AH over HB equals what? Sine 60. Therefore, answer is 8 root 3 centimeter. Also, by the same method, in triangle BOH, angle BHO equals 60. Remember, my dear student, measure of H angle 120, but in triangle BHO measure angle equals 60. Therefore, BO equals 6 root 3. The set of forces consists of two couples. What is the magnitude? M1 is 3, 3 with arm AH or the distance. M2 is 8, 8 with arm BO, the distance or perpendicular. Then we say that the set of forces is equal to a couple whose moment M1 plus M2. We find M1 3 times 8 root 3 in positive direction anti-clockwise, but 8 and 8 with clockwise with negative direction, 8 times 8 root 3. Therefore, the moment of couple negative 40 root 3 kilogram weight centimeter. Another example. ABCD is a rectangle, which AB equals 9 centimeter, BC equals 12 centimeter. An isosceles triangle is drawn outside that rectangle with base AD and height 8 centimeter. Forces of magnitude 36, 48, 36, 40, and 40 gram weight are applied along AB ray, AD ray, CD ray, DE ray, and EA ray respectively. What is the required proof that the system of forces is equivalent to a couple, and find the norm of its moment. Solution. My dear student, look at A, B, C, D is a rectangle. We have isosceles triangle AED, such as AD base of triangle applied on M, on a rectangle. In triangle EXD, EX perpendicular to AD. Measure angle X is 90 degrees. Therefore, we have EAE equals ED, isosceles. The length of each equals 6 square plus 8 square equals 10. Then the isosceles triangle EAED is its side is 10 centimeter. The first couple form from 36 and 36. Two forces equal in magnitude, opposite direction. The first act at CD, the second act is at AB. Distance between them is 12. Then the moment or the first moment of the first couple, which form from 36 two forces, distance 12 equals 36 times 12. Answer 432 gram weight centimeter. This is M1. The second three forces act along triangle ADE in the same cyclic order. What you mean, my dear student? My dear student, look at ADE. The force 48 acts at AD ray, which its side 12. Remember, 48 force, side 12. If we divided 48 divided 12 equal what? Equal 4. Look at the force 40, which act at DE. Acts at DE, its side length 10. When divided 40 by 10, answer is 4. Also, the force 40, which acts at EA, its side length 10. When divided 40 by 10, answer is 4. What you mean? The ratio between forces and sides of triangle ADE in cyclic order is constant, 4. Then these forces form a couple. What is the couple moment? 2 times the ratio of the couple, or K, times area of triangle ADE. This is the moment of couple. When three forces act as three sides of a triangle in cyclic order, the ratio is constant between the force and sides, then moment of couple 2K times area of a triangle. We deduce that, my dear student, F over L equal 48 over 12, 40 divided 10, 40 over 10, answer is 4, is the constant ratio. Therefore, moment of this couple M2 ratio times area of triangle. We know that area of triangle have base times height. We multiply 4 times 2 times half times AD times EX. Therefore, the moment of this couple 384 gram weight centimeter. The system is equivalent to couple and moment is M1 plus M2. We add moment of two couples, then we deduce that the moment of couple is 116 gram weight centimeter. Another example. ABCD is a trapezium in which AD parallel to BC. Measure angle ABC equals 90 degrees. AB equal 8 centimeter, BC equals 17 centimeter, AD 11 centimeter. Forces of magnitude 22, 16, 34, and 20 gram weight act along DA ray, AB ray, BC ray, CD ray, respectively. Prove that the system is equivalent to a couple and find its moment norm. Then find the two forces was acting along AD ray and CB ray so that the system will be in equilibrium. Solution. Look at, my dear student. In the opposite figure, we have ABCD is trapezoid or trapezium. The trapezium ABCD, BC equals 17 centimeter and AD equal 11 centimeter. When we draw DH perpendicular to BC, look at DH divided BC into two parts. The first part equal 11, BH equal AD. The second part equal 6 centimeter equals HC. Then we deduce that DH equals what? 10 power 2 minus 6 power 2 equals 8. Pythagoras theorem under square root. We have, look at, my dear student. The cyclic order 16 over 8, 34 over 17, 20 over 10, 22 over 11. What you notice? There is a constant ratio between the forces and all sides which act along it. 16 over 8 to 37, force over 17 centimeter is 2. 20 over 10, also 22 over 11 is constant 2. Therefore, we deduce that the set of forces form couple. What is its moment? Excellent student. This rule 2 times the ratio K times area of trapezoid. We know that area of trapezium have base 1 plus base 2 multiply height. Base 1 AD, 11, base 2 BC 17, height DH equals 8. And the ratio or constant ratio is 2. Multiply, we find the moment of this couple. Look at, my dear student, the moment, the ratio times twice area of a trapezium. 2 times 2 times this area of trapezium, base 1 plus base 2 over 2 times height. Answer is 448 gram weight centimeter. Let the two forces F and F, the second required. Negative F times 8 plus 448 equals 0. Or equivalent couple means the couple which act or which form from two forces F and F which acts at AD and HB represent couple or equivalent couple 448. Then we deduce that negative F times 8. Why negative? Because the two forces act at AD and HB with clockwise. Plus 448 must be equal 0. Then we deduce that 8F equals 448. Then the value of the force F equals 56 gram weight. Then we deduce if we have other couple forms of two forces F and F which act at AD and HB and the distance between them 8 centimeter, we find the value of F by using the equivalent couple 448 divided 8. Answer is 56 gram weight. This is the value of the force F. By the end of the lesson, my dear student, we know that the couple is very important lesson. Two forces equal in magnitude, opposite direction, distance between them, or we have different distance. We know that, my dear student, we have two signs of couple, positive and negative. When the two forces act along anticlockwise, this is the positive direction. But when two forces which act with clockwise is negative direction. Remember, my dear student, also, if we have three forces which act along three sides of a triangle in cyclic order, then the ratio between them is constant. The moment of this couple equals twice area multiply the ratio of the force and the side. The constant K, when also more forces act along rectangle, trapezium, or any geometric shape, and the constant is K equals the ratio between the force and side, then we deduce that the system form a couple. The moment of the couple in this case, we find the value of K multiply twice area of this figure. This figure is trapezium. We know that the trapezium area equals B1 plus B2 over 2 times height. Area of a rectangle, length times width. Area of rhombus, D1 times D2 over 2, or have product of two diagonals. Also, area of a square side times side, or diagonal power 2 over 2. It is very important to save the areas of all geometric shapes which we study in the previous year. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.